And welcome to week number 4. We are going to be discussing the first couple sections of chapter 4 this week, which have to do with some propositions. So we're going to do a lot of pattern recognition, a lot of keywords that are we looking for, going to be a lot of new stuff. This is going to be I'm sure most of you have never seen this stuff before, so again, don't be afraid. You're going to practice. You're going to get stuff wrong. It's okay. Just keep practicing, keep studying. Here we go. Section 4.1 is called the components of categorical propositions. So every proposition or statement is just a sentence that's either true or false. When a proposition relates two classes together, it's called a categorical proposition. And those classes are either called the subject term or the predicate term, depending on their position in the statement. Either all or part of the class denoted by the subject term is included or excluded from the class denoted in the predicate term. So let me give you some examples. So here are 4 types of categorical propositions. Okay, we give them letter names A, E, I, and O. A is all S are P. So S is the whole subject class, and that is included in the predicate class. So like all cats are animals, right? Because cats are a subset of animals. So that kind of thing. E is no SRP, like no cats are fish. Okay, the whole subject class is completely excluded from the predicate class. I is some SRP. That means some of them, like some dogs are Dobermans, right? Okay, makes sense. And then an O would be some S are not P. So part of the subject class, part of them are not excluded from that. Some of them are. So that one, I find O to be a little tricky personally. Standard form. You're going to see these qualifiers, all, no, or some. The subject term is a noun or a noun phrase. The copula, that's the link between the subject and the predicate. Those are usually like are or are not. That's our copula. And then the predicate term is also a noun or a noun phrase. So all of these come together to make our 4 different, right? Our 4 different. So, and I've made the same chart with those, but here's so A is, here's your quantifier, here's your subject, here's your copula, here's your predicate. And I did that for all 4 of them. So that just helps you kind of get used to how it works. Like some cars are not trucks. Some cars are trucks. Some cars are built on truck chassis now, which is kind of interesting. So, all right, some things to remember. They have those 4 distinct components, A, E, I, and O. You cannot combine them. Okay, they are 4 separate things. Subject and predicate do not mean the same thing in logic that they do in grammar. So don't get that confused. A lot of people do. The form all S are not P. That is not a standard form. That was not one of the ways. Okay, there are 2 ways of translating any statement that says all S are P. There's 2 ways. No S, so all S are not P, sorry. You can translate that as no S are P, or you can translate it as some S are not P, which is why it's not a form, because it can be translated those 2 different ways. And each form has to be its own thing, has to be unique. So, some examples. Okay, so read this, press pause, see if you can write down the quantifier, the subject term, the copula, and the predicate term for each of these 2 examples. All right, let's see if you got it correct. Dun, da, da. There are the answers. Again, some of this may take some practice. Don't feel bad. I know that I have to practice logic a lot because sometimes it's really tricky. All right, here's some more examples. Try these 3. Same thing, write down your quantifier. All right, let's see how you did. There's your answers. Again, keep practicing, okay? So that's all we cover in section 4.1. In 4.2, we talk about something called quality, quantity, and distribution. So we're going to take those 4 propositions and we're going to talk about their quality, and this is either affirming or it's either affirmative or negative depending on whether it affirms or denies class membership. So your affirmative propositions are your A and your I, all SRP, some SRP, right? That's affirming them. The negative propositions, the ones that deny class membership, are E and O, no SRP, some S are not P. Okay, those are negative propositions. Okay, so quantity, another word, quantity means it's either universal or it's particular, depending on the statement. So your universal propositions are your alls or your nos, right? The universal affirmative, which is A, and your universal negative, which is E, because there's no S. Your particulars are the sums. So your I, some S are P. That's a particular affirmative. O, some S are not P. That's a particular negative. So I have had students who've tried to come up with all different ways. They've sent me stuff over the years. Like I had a student who sent me this, which helps them remember which is negative and which is affirmative. Honestly, I look at this and it makes no sense to me. I just remember them. So you might have to create a way for you to remember all this stuff. But keep looking for those. You might find something online that helps you remember. So I'm just trying to put stuff out there that may help you. This personally does not help me, but it helps some people. All right, distribution. Okay, the third thing they talk about in this section is distribution. And distribution is when you make an assertion about every member of the class denoted by the term. So it applies to terms themselves, not the actual proposition itself. So is something being asserted about every member of S or the P class? That's what you want to ask yourself. So there's some mnemonic devices that might help you. Unprepared students never pass. USNP stands for universal distributes the subject. Negatives distribute the predicates. So that helps me. I like mnemonics. That helps me remember stuff. The next one is any student earning B's is not on probation. A distributes the subject, any student earning B's. E distributes both. I distributes neither, is not. And then on probation is O distributes the predicate, OP. I don't know about you guys, but that's more helpful to me than like drawings and stuff. So again, any way you can remember this stuff, it doesn't matter to me. I did grab this chart right out of your textbook, which is very nice. It's got the form, it's got the quantity, it's got the quality, and it's got the distribution, whether it's the subject or the predicate that's distributed or undistributed. So honestly, I just think forms like charts like this are more helpful to me when I'm learning. Now there's another way that you can represent these propositions, and that's using Venn diagrams. And these can be a little tricky, and we're going to use Venn diagrams in chapter 4 and in chapter 5. So pretty much the rest of the course, we're going to talk about Venn diagrams at some point each week. So definitely practice these Venn diagrams. It's going to take you a little practice. So here is the Venn diagram that represents each of our propositions. So there's all SRP. That means every S is contained within P. So notice the S circle is completely contained within the P circle. Okay, no SRP means there is no overlap. S and P are completely separate. So no overlap between those two circles. Some SRP, we put S inside of P and we put a little asterisk next to it because some of S are inside P because they are P. But in the next one, some S are not P. S with an asterisk, but it's outside of P because they are not part of P. So definitely might need to practice these Venn diagrams things because they will get more and more complicated as we move along. All right, so let's try some examples. Okay, so for each of the following, I want you to identify the letter name, the quantity, and the quality, and then state whether the subject or the predicate terms are distributed. You might need to go back to that chart and look at it and use that. I know I do because that's how I remember everything is that chart. So press pause. Welcome back. Let's see how you did. Here are your answers. Let's try another couple more examples. Okay. Change the quality in these two, but not the quantity, and rewrite them. So all I want you to do in each statement is I want you to change the quality, but not the quantity. All right, let's see how you did. And again, if you get these wrong, do not feel bad. Practice makes perfect. I hate to say it. I'm starting to sound like my piano teacher from the 3rd grade. All right, here we go. Another. On this one, change the quantity, but not the quality. All right, let's see how you did. All right, let's try some more examples. In these examples, change both the quality and the quantity. Here you go. Hopefully you're getting better. Okay, so section 2, you're going to see a lot of examples like this in your homework that you're going to have to work on. All right, and the last section that we're going to cover this week is Venn diagrams and the modern square of opposition. All right, we're going to talk a lot about some three very famous people who did work in philosophy. Okay, Aristotle's the first one. Aristotle held that universal propositions about existing things do have existential import. They are important because you can't really talk about things that don't exist. Like we could talk about unicorns all day long, but does it matter because they don't exist? Same kind of thing. George Boole held that there is no universal proposition that has existential import. I don't know if I necessarily agree with him, but whatever. John Venn, who perfected Boole's theory, kind of like worked upon it, developed this whole system of creating diagrams to represent the information they express. So Venn diagrams come from philosophy. I hate to break it to you. They aren't a math thing. They're a philosophy thing. So there are two ways that we can interpret categorical positions. So the first is from the Aristotelian, can't even say it. From Aristotle's standpoint, there we go, I'll just say it that way. Things that actually exist. And Boolean is not going to even attempt, there's going to make no assumptions. Whether it's existing or not, doesn't matter. We're not going to make any assumptions. That's why I don't like Boolean, because I have a hard time talking about things that don't exist. Like, why am I talking about it if they don't even exist? But the two views really only differ in regards to A and E. I and O, there is a positive claim about existence, that things actually exist. So it's only A and E that this affects. Okay, so here we go. So over here, okay, so here are some examples. So before I get to this on the left, let's talk about this on the right. Here are my 4 propositions. So all S are P. All SRP would be this right here, right? These are all the S's that are P's. And I know it seems weird. Shading is emptiness and X is existence. So no SRP, this right here. These are the no S that are P. This is empty. Some SRP. So in that overlap, we're going to put an X there because there is existence. Some of the S are P. Over here, some S are not P. So some S cannot be part of P. So you can X right there. This is where things can get really crazy. So you really have to pay attention here. Okay, so for example, here's a Venn diagram. We really need to talk about what these 4 sections of the Venn diagram mean. And I think it's easier if we talk about it in words. So this circle over here represents Americans. This circle represents farmers. So section 1 is Americans that are not farmers. Section 2 is the overlap, where you have Americans and they're farmers, right? They're American farmers. Section 3 is farmers, but they're not American. And 4 is people who aren't American and aren't farmers. We have 4 very distinct sections of this Venn diagram that we have to take into consideration, and they all mean something. So that is definitely something. Venn diagrams can be really challenging. Personally, I find them challenging. I mess them up quite often, so because they're very detailed. Every little detail matters. All right, so here's the interpretation of those 4 diagrams. So all SRP means no members of S are outside of P, which is why, if you go back to the Venn diagram, notice anything outside of P is this is all emptiness, right? The shading represents emptiness. So this doesn't exist because all S have to be inside of P. Hopefully that makes sense. No SRP means no members of S should be inside P. And if you look back, look at no members of S. This is the circle S. All of these are empty because they cannot be part of P. Making sense? Hopefully. Some SRP, at least one S exists that is a P. So that's why they have the X in the overlap. And then some S are not P. So there's at least one S that exists that is not part of the P. So that's why there was an X in the S part, but not in the overlap part. So you will definitely have to practice a little bit of these. So the process for testing arguments when you're using these Venn diagrams, here's a step-by-step guide. Number 1, determine the letter names for both the premise and the conclusion statements. Draw a Venn diagram for the premise. Draw a Venn diagram for the conclusion. Okay, what do you do when you have a false statement? When you have a statement that begins with the phrase, it is false that, you're going to draw the diagram for the contradictory proposition. For example, if you have an A statement, but it says it is false that all S are P, A is false, you're going to draw the diagram for O being true, because that's the contradictory. And that was in that, remember that visual I showed you before? Let me go back to it real quick. There's the visual. So notice A and O are contradictory. I and E are contradictory. So we can go back to that slide. Oh, if I can find it again. Here we go. So if it is false A, then you can draw the true of O. If O is false, then you would draw the true of A. So that can get really confusing. So if you find that that square of opposition that I showed you before helps you, then please feel free to use it. All right, so if it's given you a false A, you draw O. If it's given you a false E, you draw I. If it's giving you a false I, you draw E. And if it's giving you a false O, you draw A. Good times, right? Good times. If the two diagrams express the same information, meaning they are identical, then the argument is valid. Very important to remember that. So this is what we call the modern square of opposition, this little drawing right here. Okay, A and O are contradictory, I and E are contradictory. That's what those arrows inside the square stand for. And then it pairs them up. So I and E, if you pair those up, it's logically undetermined. It may or may not be, right? So you can't just go around. You have to go in the middle, right? You have to go across in the middle. I's and O's, E's and I's. You can't go to A to E. That doesn't really tell us anything. All right, so how do you test for arguments for validity using that square? So you're going to symbolize the argument. You're going to draw a small square. You're going to plot the truth values. Are they true or are they false? Onto the square. Ask yourself, are they diagonally opposed? And B, do they have opposite truth values? Is one true and the other false? Okay, if the question to either of these is no, then the argument is invalid. If you'd answered yes to both of these, then the argument is valid. Seems simple, but yet can be really crazy. So we're going to do some examples. Immediate inferences are something we need to talk about real quick. They have only one premise, which proceeds immediately to a conclusion. So this can happen when you're talking. So some trade spies are not masters of bribery. Therefore, it is false that all trade spies are masters of bribery, right? Because if some of them are not masters, then that means some of them are, right? Or it's false that all of them are, because we know some of them are not. All right, unconditionally valid arguments are valid from the Boolean standpoint. Okay, so we don't worry about existence. So if you are drawing, it is false that all A are B, we diagram the flanks. So here, right, all A are B, this is how we would draw it. If that's false, this would just mean instead of being non-existent, we would have some sum. If all of the A are B, that means some of them now, it is false means some of the A would be B. So something would exist here rather than not. Okay, if it's false that A are B, here's some A are B. Here is the false, right? If some of them are not, then this has to be empty. So that's why this would have empty space here instead of having an X. No longer is there some, it's empty. Some T are not M. So here is some T are not M, right? There's existence here in the T that aren't M's. It is false that all T are M. Notice those two are exactly the same. All T are M. If that's false, that means some T are M. So these can be so tricky. I can't stress enough how you may need to practice these over and over again. So please read your book a couple times, watch all the videos that I have posted. Don't be afraid to go on YouTube and look for some more. Sometimes you just need to hear it over and over again before it sinks in. So here's two more examples. It is false that all M are C. And then there's no M are C. Notice they're not the same, right? Not the same. Finally, all S are W, some S are W. All S, it is, and this is some. So it's important that you can see those relationships in the Venn diagrams and what they stand for. All right, the existential fallacy that we talked about back in section 3 is just a formal fallacy that occurs whenever an argument is invalid merely because it lacks premise existential import. It's very easy to detect. all you have to do is look for a pair of diagrams in which the premise diagram contains shading and the conclusion diagram contains an X. And there are exactly 8 inferences forms that commit this fallacy. So you can memorize all 8 if you want to, or you can just kind of keep this list in your back pocket. But here are the 8. So here are the first 4. And here are the last 4. So that is all 8 where this existential fallacy can occur. All right. Let's try some examples. We can try our hand at drawing Venn diagrams. And listen, this takes practice. I'm not going to lie. So try to draw these two. And my advice is when you read it, change it to letters, right? So all E are M, right? All electric motors are machines that depend on magnetism. All E, electric motors that are machines. Okay, R, M, machines that depend on magnetism. Okay, draw that. And then draw some political campaign. So some P, R, attempts to discredit opponents. Maybe all P are, something. A or D. I don't know, whatever. Whatever you want to, whatever letters you want to use, it doesn't matter. All right, let's see how you did. Here is the correct Venn diagrams for each. Hopefully you did well. It's hard when you're first starting out. All right, here's some examples using the modern square of opposition to determine whether the following are valid or invalid from the Boolean standpoint. Okay, so read these, press pause, and then write down whether it's valid or invalid. And here are the answers. Let's see how you did. They are both invalid from the Boolean standpoint. Remember, Boolean doesn't care whether it exists or not, so. All right, some more examples. Use Venn diagrams to evaluate the immediate inferences in part 2 of this exercise. So we don't have to worry about part 2. Identify any that commit the existential fallacy. Okay, so notice you've got premise, right? First statement, conclusion, right? So do both of them, see if they're the same. Okay, do that for this one and do that for this one. All right, let's see how you did. So here is your premise, here is your conclusion. Notice we've got empty space here and an X here. So this is invalid because that is that existential fallacy. Anytime you have an empty space and an X. Okay, that's existential. Okay, this is some CRO, and this is no CRO. Again, also invalid. If that had just been all colored in, we would have exactly the same thing. All right, here we go. Last example. All right, use Venn diagrams to evaluate the immediate inferences. Identify any that commit the existential fallacy. Okay, so again, you're going to do your 2 Venn diagrams. Okay. And then tell me if any of them commit the existential fallacy. So press pause, take a minute. All right, let's see how you did. All right, here is your premise, here's your conclusion. That is valid. Notice they're exactly the same. Yay, that's what you want. That's a valid argument right there. All right, here, some C or D, all D or C. Notice, empty space and an X. That's our existential fallacy, so that's invalid. All right, so you'll definitely need to practice these Venn diagrams. It takes time and practice. There's no magic pill. I wish there was. And next week we will wrap up chapter 4. More Venn diagrams are coming your way next week, so make sure you practice.